to the third power, we want to find the x-intercepts and the roots. So let's begin by looking at what we have. We have a factor here at x minus 2. We have another factor here at x plus 4 squared, and then a third factor with x minus 5 to the third power. Now, I'm going to label these factors so you guys know what I'm talking about. Basically, anything in parentheses is considered to be a factor. So all of these are factors. And it's based on these factors that where we need to find kind of like what x values x needs to equal so that each factor goes to 0. It's pretty simple. So for example, here in the first factor, x minus 2, x needs to equal what to equal 0? 2. Over here with x plus 4, x needs to equal negative 4. And over here with x minus 5 equal x minus 5 to the third, x needs to equal what? 5. Okay. So based on these, we can go ahead and write our x-intercepts. Don't forget to write these as coordinate points. So we should have the point 2, 0, negative 4, 0, and 5, 0. A total of 3 intercepts. Now, we talked about this last class. We said that a root and an x-intercept is the same thing. And yes, while that is true, we need to elaborate a little bit more. Just because you have an x-intercept doesn't mean that you have a single, double, or triple root. You have to determine that based on how the graph behaves. Now, in our case, we don't have a graph to go off of, so we have to kind of look at the factors. And specifically, we're going to look at the exponents. So, for example, the factor x minus 2, is that a single, double, or a triple factor? What is the exponent for the x minus 2 factor? Do we see an exponent for x minus 2? We don't. So because we don't see an exponent, it's actually raised to the first power. So 2 is a single root. And so we have to show that in parentheses. We have to say, okay, 2 is a single root. And we know it's a single root once again because the factor x minus 2 does not have any exponents. Moving on to x plus 4 squared, negative 4 is going to be what type of root? What is the exponent for x plus 4? It's 2. It's a second power. So this will be a double root. So negative 4, we have to label that as a double root. And lastly, we have 5. And what do we think 5 will be? It's a triple root. So 5 is a triple root. Now, altogether, because we have a triple, double, and a single root, what should we expect the degree of this function to be? What is the degree of this function? 6. Very good. So 6 is correct. You take your triple and you add it with your double. 3 and 2 is 5. And then you add it with your remaining single. 5 and 1 is 6. Okay. So we would get a 6-degree polynomial. Now, we're going to go ahead and introduce the idea of multiplicity to you guys, which is very simple. Let's go ahead and fill this out. When an equation has a squared factor, think about what this means. When an equation has a squared factor, this means that when your factor is being squared, it has an exponent of 2, then you will have a multiplicity of 2. Now think about what multiplicity could mean in this scenario. Multiplicity kind of sounds like multiplication. And what essentially we're trying to tell you is if you have a multiplicity of 2, it means that it's happening twice. It's repeating. Okay, it's being multiplied by itself 2 times. That's kind of what we mean or what we intend to say when we say multiplicity. Okay, so keep that in mind. The next one is going to be the following. It's going to be when an equation has a cubed factor. Then that root has a multiplicity of blank. What do we think goes in that blank? 3. 3 would be correct. Okay. So think about cubed factor. That means it's a factor to the third power. So if it's a factor to the third power, then it has a multiplicity of 3, meaning it's repeating 3 times. It's a triple root, essentially. So a root's multiplicity is the exponent or the power of its factor in the polynomial. Okay, that's basically how you determine multiplicity. It's based on the exponent of the factor. Okay, so if it's to the first power, it's a multiplicity of 1. If it's to the second power, multiplicity of 2. To the third power, multiplicity of 3. And you kind of get the idea. Okay. All right. We're going to skip the next part, which says go back to Desmos and work on screens 12 and 14. We're actually going to go to the next page, and I'm going to give you guys about 8 minutes. Pair up with the person next to you. You're going to fill this in. It's a partner matching activity. Let me read the instructions so you guys know what to do. It says, for each graph below, identify the roots from the choices below. Note that there are more choices of roots than there are graphs. So you are going to have 2 options left over. You're going to associate the graph to the correct letter description. Okay? So I'm going to set the timer right now to 8 minutes, and then we'll check back in approximately 8 minutes. So let me begin with Christian's group. Top left is a, what letter did you put for this one? F. Can you read the description, please?
This function has a root at -2 and a double root at 3 with a negative y-intercept.
Excellent. So we have a single root at -2 and a double root at 3 with a negative y-intercept. So this would be F. Next group. So after that one, let's go one down. Let's go to Kyle's group. What is the description for this one?
This function has a root at -2 and a triple root at 3 with a negative y-intercept.
So it has a root at -2, the triple root at 3, and a negative y-intercept. So this one would be G. Excellent. Next, we have the one underneath that. Let's take a look at what we have. Let me hear from Omar's group. H. H is correct. Can you guys read the description for H? Excellent. So we have they're all single roots, by the way. So single root at -5, single root at -2, single root at 3. By the way, I had some people ask me how you can determine if you have a single, double, or triple. At least single, double we've seen before. Triple is kind of new. At least we're seeing that today. So single goes through the point. I don't even want to refer back to that. But single goes through the point. Double bounces at the point. But triple roots go flat. Okay, so they kind of go flat at the point. So let's look at this example top right. Notice how at 1, it's flat. And so when you see that, when you see it go up and then flat and then up again, that's an example of a triple root. So let me hear from Paulina's group. Top right is an example of which letter? Which one? D. And can you read the description for us? Excellent. So we have a double root at -2 and a triple root at 1. Moving on to the one underneath that, what would the description be for this one, Ella?
A.
A is correct. Can you read the description for us?
This function has a root of -2 and a double root at 3 with a positive y-intercept.
Excellent. Single root at -2, double root at 3 with a positive y-intercept. Finally, we have bottom right, and let me hear from Leo's group for this one. B. Go ahead and read the description, please. Excellent. So single root at -2, triple root at 3 with a positive y-intercept. Okay, very good. So let's move on to the last example, example 3, and then we will conclude with this lesson. So, everybody in example 3? All right. Now, if we read a description, it says that we are given a third degree polynomial. Now, you've seen it plenty of times in this packet and other packets that there are typos. So you don't always want to believe what you read. You want to make sure that you double check, okay? Because even if it says third degree here, it's actually a typo. We're going to find out that it's not a third degree. And how am I supposed to figure out the degree just by looking at the graph? What did I show you guys last class? Well, aside from the roots, we talked about the degree is equal to blank. Go ahead and look on page, I believe it was page 14. Changes in direction. Very good. So if you notice, first we are going down. And then we go flat. And then we go down again. And we finish by going up. So this is a what degree polynomial? How many changes in direction do you see? It's a fourth degree polynomial. We can confirm that it's a fourth degree polynomial because look at the end behavior. Where are both ends of the graph going? In the same direction. Okay, so that was a typo. It's not a third degree. It's actually a fourth degree polynomial. And now that we know it's a fourth degree polynomial, let's focus on the roots. We have an x-intercept at 1 and 0. Is this a single, double, or triple root at 1, 0? Single. Now let's look at negative 2 and 0. Is this a single, double, or triple? Triple. Very good. So we can go ahead and write our equation. Y equals a. X minus 1. Since that's a single root, our factor will have no exponent. It'll just be x minus 1. Then we have x plus 2, and because that's a triple root, the exponent will be a 3. Okay. Great. So we have our factor set up. We just got to solve for a. So let's pick a point like the y-intercept, which is 0 and negative 4, to serve as our x and y values. So we can replace that into our equation. So negative 4 equals a. 0 minus 1, 0 plus 2 to the third. And let's solve for a. So 0 minus 1 is negative 1. 0 plus 2 is 2. What is 2 to the third power? 8. Okay. So we solve for a. We figure out that a is 1/2. Are we done with the problem? No. What is there left to do? Rewrite the equation. So y equals 1/2 x minus 1, x plus 3 to the third. Sorry, x plus 2 to the third power. To the third power. So this right here is our final equation. Okay. All right. So overall in this lesson, we have shown you how to find the value of a with single roots, how to find the value of a with single and double roots, and then how to find the value of a with single, double, and triple roots now. Okay. So you will get a chance to practice. I will give you guys some time right now to go back on Desmos and show your work for screen 15 and 17. So let me go ahead and set that up for you guys. We should have that. I don't know if it's Chrome. Is it Chrome? Yeah. Okay. So it's already set up for you guys. Just log in and let me give you about 10 to 15 to get started.